For decades after the Apollo and Luna missions, the Moon kept its secrets while humanity turned its gaze to other worlds. The last return of samples by the Soviet Union in 1976 marked the end of an era. And then, seemingly overnight, the lunar race resumed. New SpaceX rockets soared into the sky, NASA developed the Artemis program, and China quietly ventured where no one had gone before. Whispers began about strange discoveries on the far side of the Moon. What was really found beneath the lunar dust, and why is everyone going back? To begin, let us provide a bit of context. China's lunar exploration began relatively recently, in the 2000s, following an ambitious step-by-step plan. The China National Space Administration launched a series of Chang'e orbiters and landers named after the moon goddess to systematically study our nearest celestial neighbor. Their goals combined science and strategy, making the rise of China as a space power. Chang'e 1, launched in 2007, was China's first lunar orbiter. It created a 3D map of the moon's surface and analyzed soil composition. Notably, Chang'e 1's instruments detected signs of helium-3 in the regolith, an early hint at China's resource ambitions. A follow-up orbiter was launched in 2010 with higher resolution cameras. Chang'e 2 surveyed potential landing sites for the next mission, flew only 9 miles above the surface to photograph possible landing zones and verify terrain safety. Just 3 years later, China achieved its first soft landing on the Moon. The spacecraft touched down on the near side in Mare Imbrium and deployed the U-2 rover. This was the world's first lunar landing since 1976, ending decades of silence. U-2 rode the Gray Plains carrying an ultraviolet telescope, first lunar observatory of its kind. In 2019, Chang'e 4 was launched, a mission that would make history. Initially a backup for Chang'e 3, it was repurposed for an expedition to the Moon's far-facing side. Its goal is to become the first spacecraft ever to land there, an achievement no other nation had managed. China's methodical program demonstrated not just technological prowess, but also geopolitical ambition. CNSA, indirectly overseen by the military, pursued dual objectives: scientific discovery and strategic prestige. Some analysts believe China's focus is driven by the pursuit of strategic resources, marking the start of a new lunar energy race. In other words, beyond national pride, the key motivation lies in the untouched riches of our satellite: metals, water, and nuclear fuel. So, on January 3, 2019, Chang'e 4 descended into the alien night of the Moon's far side and made a soft landing in the von Karman crater. This crater lies within the colossal South Pole Aitken Basin, one of the largest known impact structures in the solar system. The significance of the far side is immense. It always faces away from Earth, hidden from our radio chatter, and it had remained unexplored by previous landers. Scientists had long hoped to study its ancient terrain and untouched radio environment, but the technical hurdles were enormous. Because the bulk of the Moon blocks direct communication, no probe can contact Earth from the far side without a relay. China proposed an elegant solution: a dedicated satellite called Queqiao, or Magpie Bridge. In May of 2018, Queqiao was positioned at the Earth-Moon L2 point, hovering beyond the Moon with constant line of sight to both Earth and the far side of our satellite. This relay was critical. From the moment Chang'e 4 began braking near the surface, its landing commands were relayed through Queqiao. Moments after touchdown, the probe called home via this communication bridge. Nonetheless, the landing site itself remained in total radio silence, an ideal location for new experiments. Here, Chang'e 4 deployed its Yutu-2 rover, which rolled onto the gray powder 12 hours after landing. This is a first for humanity and an impressive accomplishment, praised NASA Administrator Jim Bridenstine as American scientists applauded the feat. Now, from the far side, Yutu-2's cameras captured a landscape no human eye had ever seen up close. A pitted plain under a black sky. The geology of the far side intrigued researchers. It lacks the dark lava seas that dominate the near side. Instead, it features a thicker crust riddled with craters. By exploring it, the probe could finally help answer a long-standing question. Why do the two faces of the moon differ so dramatically? And so, Chinese missions began to excavate, or rather unseal, a multitude of findings, ranging from exotic materials to hints of resources that could serve as fuel for future colonies. However, these findings spark not only curiosity, but also provide answers to many long-standing questions. And topping the list, of course, is the isotope helium-3, a treasure in the dust, and one of the most talked about lunar resources. Rarely found on Earth, it exists in abundance in lunar soil, deposited over centuries by the solar wind. Theoretically, helium-3 could power nuclear fusion reactors, offering clean energy on an immense scale. Chinese scientists emphasized this potential. In 2020, among the samples retrieved by Chang'e 5, a new mineral was discovered given a name of Changasite Y, which interestingly contains traces of helium-3. Its appeal is striking. Just 1.4 ounces of helium-3 could produce as much energy as 5,000 tons of coal. Estimates suggest that more than 1 million tons of helium-3 are present in the lunar regolith. And that's enough to power Earth for thousands of years. Unsurprisingly, Chinese lunar orbiters and rovers have been mapping the distribution of helium-3 and analyzing regoliths since the very beginning. This valuable gas may become the gold rush of future lunar mining. And the Chang'e missions are effective prospectors, surveying the most promising sites. Yet not all discoveries were so predictable. Mid-2019, operators of Yutu-2 noticed something unusual in a small crater, a shiny textured patch that was different from the surrounding soil. The discovery of the mystery gel stirred the internet. What could be sticky or liquid on an airless moon? Volcanic glass, meteorite melt, or something even stranger? Chinese officials initially withheld any photographs, fueling intense speculation. When the images were finally released, they revealed a glistening dark substance that accumulated between the dust and rocks. Scientists who analyzed its spectrum identified it as breccia, soil and rock fused by the heat of a meteorite impact. In other words, a patch of glassy lunar rock. Likely rich in minerals like olivine and pyroxene, had melted into a smooth mass. Not exactly alien slime, but still a thrilling find. It resembled melted regolith samples from Apollo missions, but it was discovered in a completely new location. This glittering patch told a story of high-energy collisions that had shaped the moon's hidden face. Alongside all this, amid the gray wasteland, Chang'e 4 also carried a tiny biosphere experiment. A sealed container the size of a bucket, filled with soil, seeds, and insect eggs. In January 2019, mission scientists announced a groundbreaking event. A cottonseed had sprouted inside the container on the moon. The news came with a photo of a delicate green shoot emerging under lunar gravity. The first plant in human history to grow on another planetary body. It was a symbolic glimpse into future greenhouses. However, the little plant didn't live long. 2 weeks after landing, lunar night fell and temperatures inside the container dropped to negative 62 degrees Fahrenheit. Without sunlight, the sprout died as expected once the heaters shut down. But in those short days, it proved that Earth life can begin to grow even if in such distant and alien conditions. Other seeds, like potatoes and even fruit fly eggs and yeast, were also placed in the biosphere in an attempt to create a tiny ecosystem. Although they didn't hatch or grow before the cold arrived, the experiment marked a significant milestone in astrobiology. It demonstrated that astronauts could one day grow food on the moon, an essential step toward establishing long-term lunar bases. As one scientist put it, this is the first time humans have done biological growth experiments on the lunar surface. A tiny green leaf on a lifeless gray world became a powerful symbol of the possibilities to come. News of China's distant lunar achievement spread rapidly through the global scientific community, sparking a wave of hypotheses ranging from well-reasoned debates to wild conspiracy theories. In the West, many researchers welcome China's technical accomplishments and its relentless pursuit of data. NASA, although prohibited by U.S. law from official collaboration with China, still exchanged some lunar data and extended congratulations. Scientists eagerly awaited the results of Chang'e 4's work in lunar geology, and some even began to consider the potential for third-party collaboration. The far-side landing was recognized as an expansion of humanity's lunar knowledge. Could China gain an advantage in discovering resources or in installing telescopes shielded from Earth's interference? Well, such questions sparked discussion at conferences and within political circles. At the same time, the mission's secrecy, the inherent mystery of the moon's far side, fueled less grounded speculation. Conspiracy theories blossomed on internet forums and in tabloid headlines. Some wondered whether Chang'e 4 had stumbled upon something truly astonishing, perhaps evidence of alien artifacts or ancient structures hidden from earthly eyes. Reports first emerged of a gel-like substance before any images were released. Outside commentators speculated wildly, ranging from living organisms to secret bases. Similarly, in 2021, U-2 spotted a cube-shaped silhouette on the horizon, quickly dubbed the Mystery Hut. For several weeks, the internet buzzed with jokes and theories that the rover had discovered a monolith or alien cabin. The rover team played along, using the nickname Mystery House, but made no extraordinary claims. As U-2 drew closer over subsequent lunar days, the truth became clear. The cube was merely an oddly shaped boulder sitting at the edge of a crater. In fact, it resembled a crouching rabbit, quite fitting since U-2 translates to jade rabbit. Beyond aliens, there are more strategic and plausible theories. Observers note that China's space program has military ties, raising concerns about possible covert objectives on the far side. Some suggest that a base there could be used to conceal activity or even serve as a surveillance or missile launch detection point, shielded from Earth. However, there's no evidence that Chang'e 4 carried anything other than scientific instruments. Its payload was openly published and even included contributions from Europe, such as Sweden's neutron detector and Germany's radiation experiment. Nevertheless, the timing and focus of China's efforts as the U.S. and other countries also return to the moon has fueled talk of a new space race. We now understand that what was discovered on the far side of the moon is reshaping future plans, not only for China, but for all spacefaring nations. The discoveries and lessons from the Chang'e missions have had several major implications. First and foremost is the feasibility of a lunar base. The program's success opens the door to building a research base on the Moon, possibly on its far side. If humans set up camp there, they could enjoy unprecedented in astronomy radio silence. That would allow them to listen to the universe without Earth interference. However, the far side also means permanent communication isolation. Future bases will likely depend on relay satellites like the Kukaio. China has plans to build a robotic research station this decade, potentially using 3D printing to construct facilities from lunar soil. The far side is no longer untouchable, so we may one day see habitats or observatories built in locations that are forever hidden from Earth. Beyond that, confirmed deposits of helium-3 and other mineral discoveries increase the prospect of lunar mining. If helium-3 can be extracted in significant quantities, it could revolutionize energy production on Earth. Chinese scientists estimate that 1 million tons of lunar helium-3 could meet Earth's energy needs for 10,000 years. That essentially would solve global energy and climate problems. Although this is a somewhat speculative prediction and likely decades away from realization, the race for helium-3 is now part of a geopolitical strategy. The nation that first develops sufficient lunar extraction will gain immense strategic advantage in energy. China's lunar missions are laying the groundwork for assessing mining practicality. For instance, experiments have determined optimal methods for heating lunar soil to release helium-3. Unsurprisingly, China's lunar program is supported by groups like the Atomic Energy Authority. The Moon may very well become the Persian Gulf of the 21st century. Although the launched missions landed far from the poles, the results are tied to the broader hunt for water ice. In recent years, numerous missions such as the NASA La Crosse and India's Chandrayaan-1 have confirmed that there is water in the Moon's shadowed craters, particularly at the poles. Water is invaluable. It can support astronaut life and be split into hydrogen-oxygen rocket fuel. China's leadership has taken note. Upcoming landers will be sent to the polar regions to assess ice deposits. Soil analysis data from Chang'e 5 even showed hydroxyl water bound in lunar materials at mid-latitudes, suggesting that the solar wind implants H2O into the surface. With water and sunlight to generate power, the lunar settlement becomes far more tangible. China's program envisions the use of in situ lunar resources, meaning astronauts or robots could dig up ice, melt it for water, and process it into breathable oxygen and hydrogen fuel. On the far side, especially in the South Pole Aitken region, deposits of ice might be found in permanently shadowed craters. If so, the choice to explore the far side may pay off with the discovery of keys to sustainable habitation. Ultimately, the CNSA has outlined a roadmap in which the Chang'e missions pave the way for the creation of an international lunar research station with a crew in the 2030s. The idea is to build a base likely near the Moon's south pole in partnership with other countries. However, one question remains unresolved. Who owns lunar resources? Currently, the 1967 Outer Space Treaty prohibits sovereign claims to the Moon, but as countries prepare to extract resources, new international agreements or conflicts may appear on the horizon. And it's clear that the nation leading the search and use of lunar materials will wield significant influence over those rules. The Moon has become the central arena of the 21st century space race, playing out in real time. After the launch of the Chang'e 4, all major players ramped up their lunar programs. China, for its part, continues a series of missions that build on its advantage. In 2020, the next generation craft returned samples from the Moon's Earth-facing side, including the youngest lunar rocks ever found, about 2 billion years old. Then in 2024, Chang'e 6 launched, returning the first samples from the far side. It drilled into the surface and delivered about 4.5 pounds of rock to Earth. These samples are now under analysis. They may unlock new insights into the Moon's history and confirm earlier mission instrument readings. Following that, the 7th and 8th generations of spacecraft are planned for the late 2020s, targeting the Moon's southern polar regions. Their goal is exploration and possibly the beginning of infrastructure construction for the ILRS lunar base. Chang'e 7 is expected to search for water ice and study the polar environment, likely using a lander, rover, and even a small hopping probe to explore craters. Chang'e 8 will test technologies like in situ resource utilization, and this may mark the beginning of building an outpost. By the early 2030s, the People's Republic hopes to establish the core of a research station at the Moon's South Pole, open to international partners willing to operate outside the U.S.-led framework. Meanwhile, the United States has revived its lunar ambitions through NASA's Artemis program, supported by private industry, SpaceX and Blue Origin, a coalition of allied nations. The goal of Artemis is to return American astronauts to the Moon and establish a permanent presence at the South Pole. There's an unofficial finish line, the first crewed landing of this new era. Originally scheduled for 2024, NASA's Artemis 3, the first mission to land astronauts on the surface, has been delayed to 2025 and beyond. Realistically, the landing's expected around 2027. China, for its part, has announced plans to send taikonauts by 2030, developing a new heavy-lift rocket, Long March 10, with a lunar shuttle. These are tight timelines, and there's no denying that a quiet competition is underway. In 2024, Chinese officials for the first time referred to the U.S. as a direct competitor in the race to the Moon. A striking admission. A strategic report from the CNSA forecasts that in the next 20 to 30 years, China's ILRS and America's Artemis base will be operating side by side at the Moon's South Pole. The stage is literally set in the same place, sunlit ridgelines above dark craters filled with water ice, a region where both nations hope to plant their flags and build their infrastructure. It's likely that this will lead to geopolitical tension. The U.S. has signed the Artemis Accords, a diplomatic framework for resource use and conduct in space with many countries, while China and Russia are charting their own path for the ILRS. There's also concern about a land grab, not of territory per se, but of strategic sites. Both sides want to secure the best locations, places with perpetual sunlight for solar energy and proximity to ice deposits. The question of whose rules will govern this activity remains unanswered. This isn't the cutthroat race of the 60s, a more complex blend of collaboration and rivalry. Legally, NASA and CNSA cannot work one-on-one, yet intermediaries such as Europe, which has instruments on Chang'e and is also an Artemis partner, creates a web of indirect cooperation. Still, the bigger picture is clear. The space race is back, this time with the Moon as the prize for sustainable exploration and perhaps exploitation. In the 1960s, the Moon race was about beating rivals and leaving a footprint, but in the 2020s, it's about building a foothold for the future. The ultimate question may be this: will these discoveries spur cooperation for the benefit of all, or fuel a competition that divides the lunar realm? For now, the far side of the Moon is no longer in the dark. It has become the proving ground for a new era, as nations and even private companies look to the lunar surface as the next Wild West. And meanwhile, the secrets that may shape the future of our planet quietly await on the silver globe above.